Hi friends, good morning all of you. Welcome all of you to my channel on Structural Design 1. Today I am here to discuss with the design of one-way slab. In the last video we have already discussed about the type of slabs and what are the design criteria of each slab and what are the situations in which the different type of slabs are provided. Okay. Now, to design a slab, whether it is one-way or two-way slab, what are the data known to you? Number one, Lx, Ly. Lx and Ly are the shorter and longer dimensions or spans. Shorter span, longer span. Then the loads will be given. The loads means the loads include dead load, live load and floor finish if any. Right? That means all the loads will be given. Sometimes maybe the total load will be given or separately the dead load, live load and floor finish also will be given, and then the material properties FCK and Fy. Right? The characteristic compressive strength of concrete and the yield strength of steel will be given as usual. Right? So as per this data, the room size, the loads, the material properties. Right? How to design a slab? One way or two way? So today we are discussing about the design parameters of one-way slab. So what are the steps to be followed for this? Number one, first select the type of the slab, whether it is one way or two way. How can you select it? In the last video, we have seen that find out the ratio between Ly and Lx. The longer span divided by shorter span. Ly over Lx. If it is greater than 2, it is one-way slab. Right? You have seen one-way slab. That is the criteria for one-way slab. Otherwise, if Ly by Lx is less than or equal to 2, then it is two-way slab. Isn't it? So, from the given spans Lx and Ly, get the ratios and decide which slab it is, one-way or two-way. Right? So first we consider about one-way slab. That means the ratio greater than 2. That's the first step. Right? Number 2, then decide the effective depth small d and overall depth capital D. You know, the effective depth is the depth from the top to the center of the tension reinforcement, and the overall depth to the bottom, including the cover. So the effective depth plus effective cover will give you the overall depth D. So first assume the effective depth and accordingly the overall depth for the beam. That is the second step. And third one, find out the effective span LE. What do you mean by effective span? Clear span, you know, clear span is the distance between the supports, the clear distance between the supports. Effective span, the center to center distance between the supports. So how can you find out the effective span? As per the code criteria, effective span is equal to the list of clear span plus effective depth, that is one criteria, clear span plus effective depth D, or clear span plus half the thickness on the left hand side plus half the thickness on the right hand side. That means clear span plus one thickness of the support. So from these two criteria, you can decide the effective span of the beam. Right? The third step. Now, number 4, if you know the effective span of the beam, what is the next step? To find out the loads, the ultimate load. Ultimate load. The load includes dead load, lie load and floor finish. Add to get the total load and find out the maximum load also. How to find out the maximum load? You know, partial safety factor or Fs is equal to ultimate load divided by working load. Ultimate divided by working load. So to get the ultimate load, by adding these loads, multiply with the factor of safety 1.5. That is a partial safety factor. Multiply with 1.5, find out the ultimate load W. Ultimate load on the slab. Then, after that, what is the next step? If you know the ultimate load on the slab, then you can calculate the maximum SF and maximum BM. That depends upon the beam. If it is simply supported, carrying UD load, that is the usual case, the maximum SF will be at the support and maximum BM at the center. Maximum BM, maximum SF at the two supports. You know that, the SF and BM diagrams. So accordingly, if it is UD load in a simply support beam, if it is a simply support beam, then maximum BM W L squared by 8 and maximum SF W L squared by 2, isn't it? If it is a cantilever beam, accordingly take the SF and BM values. Maximum SF and maximum BM values to be calculated, right? Depending upon the type of the beam. Then number 6, find out the effective depth required. What is it? What is the effective depth required according to these loads? We have already selected one effective depth. We assumed one effective depth. But we have to check that effective depth is sufficient or not. For that, get the effective depth required, right, as per the load given. Calculated W, you will find out the effective depth required for the slab. Then 7, what is the 7th step? Find out the area of steel. Here there are two types of steels, you know. For a slab I told you, main steel at the bottom and distribution steel at the top. Main bars are provided at the bottom of the slab and distribution steel to distribute the loads or to take the shrinkage and temperature stresses in the case of slabs, right? Two types of steels to be designed, AST and ASTD, that is distribution. AST distribution steel, this is the main steel. Number 8, what is number 8? After calculating AST and ASTD, then the next one is the checking, isn't it? Checking for shear and bond. Checking for shear first and checking for deflection, not for bond, check for deflection. What is check for shear? We know already the maximum shear force occurred on the beam and accordingly find out the shear stress, nominal shear stress tau v. Compare that tau v with the tau c as in the case of beam, right? If tau v is less than tau c, then minimum reinforcements to be provided. Usually in the slab case, minimum reinforcement should be provided for the slabs because shear will be very less in the case of slabs than beams. Otherwise you have to design it, including bend up bars in the slabs to take the shear stresses. Similarly, last step, deflection. Deflection, you know, that depends upon the stiffness of the beam. How to check the stiffness? The stiffness of the beam can be calculated taking L by D ratio. What is L? The span divided by effective depth ratio. So by taking the effective depth ratio for the given design problem, compare with the parameters, the norms in the code IS 456, we will check whether it is sufficient or not. So these are the steps to be followed for designing a one-way slab, right? Two-way slab design is different, that we will discuss in the next video. So I think these steps are clear to you. Find out the ratio between Ly and Lx and get it is, whether it is one-way or two-way, right? After deciding it's a one-way slab, find out the effective depth and overall depth of the beam. We have to select it, we have to assume it first. Then effective span to be decided from the clear span as per the norms. Then find out the total loads and the ultimate load, considering the factor of safety or partial safety factor. Then calculate the shear force and the bending moment values, maximum values. And if you know that one, SF and BM values, then check the required value of the effective depth, and after that the two area of steels, main steel and distribution steel, to be calculated, and you can select the diameter and number of bars accordingly as per the IST values. And the last one, check for shear and check for deflection. From the maximum SF values, get nominal shear stress and design shear stress, compare and design the reinforcements, the number of bars and diameter. Similarly, deflection depends upon the stiffness. So L by D ratio to be calculated and check with the parameters in the code and whether it is sufficient or not for that particular slab. These are the steps to be followed for the design. I think it is clear to you all. So next video we'll do a design problem of one-way slab. Okay, thank you. One and all.